of Almighty Allah, the most gracious, the most merciful. As Muhammad, peace be upon him, narrated, if anyone travels on a road in search of knowledge, Almighty Allah will cause him to travel on one of the roads of paradise. Hello everyone, this is Dr. Tariq Masood. Thank you very much for watching my videos and your wonderful support to make this channel a grand success. We are a family, a partner. Please share and subscribe our channel if you haven't done so far. We as a team can work together to convert challenges into opportunities and opportunities into success stories. These success stories can be monetized into value addition in the world by large. Thank you very much for your precious time. Today I'm going to discuss my lecture number 5 of FCC unit, Initial Startup Procedure. Okay, before my lecture I used to read a Quranic verse. Qala Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli Allahumma Rabbi zidni ilma. O my Lord, open my chest and ease my task for me, and loose a lot from my tongue, that they may understand my saying. Allahumma Rabbi zidni ilma, O Allah, advance me in my knowledge and true understanding. Okay. Fluid catalytic cracking, FCC unit, lecture number 5. Initial startup. Okay, key takeaway points, lecture number 5. Hydrostatic pressure testing, plant inspection, commissioning of utilities, final inspection of vessels, flushing of lines and equipment, inspection and running in pumps, break in compressor, service and calibrate instruments, dry out applied heaters, leak testing, reactor regenerator dry out, catalyst loading, purging and gas blanketing. Okay, commissioning of utilities. Today we are going to discuss inspection, running in pump, break in compressor, pre-startup checks, startup procedure, service and calibrate instrument, dry out applied heaters, leak testing, reactor and regenerator dry out, catalyst loading, purging and gas blanketing. Okay, inspection, running in pumps. Prior to unit startup, all centrifugal pumps should be thoroughly checked and run in properly after a pressure testing and water flushing. Caution. Many high-head pumps are not designed to pump water. To do so can result in damage to pump internals. Check the vendor specification before attempting to run in a pump with water. Number 1. Check to see that all necessary water piping has been made to stuffing boxes, bearing jackets, pedestals and point glands. Make sure that all necessary lubal piping is installed and that this piping is not mistakenly connected to the water system. Number 2. Check arrangement to vent the pump for a priming if the pump is not self-venting. See the special connections such as bleeds and drains are properly installed. Number 3. Check strainer in pump suction lines. Strainers must be installed before aligning a pumps. A 4 mm 3 to 5 mesh strainer is provided for each pump suction line during startup. Okay, to avoid a pump damage during flushing with water, the strainers should temporarily be lined with a finer screen. Remove the screen after water flushing is completed. All strainers should be flanged and a list similar to the blind list should be kept so as to prevent a lost screen from plugging and upsetting a unit operation later on. Okay, number 4. Check that a power or steam is available for running in the pump. Check that the pressure gauge and any special instrumentations are in working order. Number 5. Water circulation on motor-driven hydrocarbon pumps can result in motor overloading if the full pump capacity is used. In this type of equipment, the capacity must be reduced by throttling the discharge through such a period. A meter can be used to determine the required throttling. Okay. Next, before lubricating, oil lubricated a bearing checks bearings chambers in the pumps to see that no sloshings, compounds or shipping grease is left in the chamber. Okay. Next, lines of the mechanical seals should be flushed with water prior to pump operation so no dirt gets into the seal and skewers the seal faces. Okay. Last, it is extremely important that the proper type and viscous oil and a proper grade of grease is used to lubricate the equipment as per vendor or manufacturer instructions. Okay, break-in compressor. The compressor will be started and operated according to manufacturer instructions. We will discuss on later stage. Next is the pre-startup checks for the compressor. Okay, pre-startup checks. There are several points that must be checked before the compressor is ready to run. Number 1 or A. The lube system must be cleaned and temporary 10 angstroms of filter with 20 mesh wire screen backings must be installed at the lube supply to each bearing. The lube oil is then circulated with the 20 angstroms filter being frequently replaced. When the filter stay clean, they can be removed and the lube oil system is ready for service. Number 2. All trips and alarms, high discharge temperature, low lube oil pressure, etc. must be checked and be operational. In addition, the auxiliary lube oil pump auto start must be functional. Number 3. The cooling water to the lube oil cooler must be commissioned. Number 4. A cold alignment check must be made before the machine is allowed to start. Okay, compressor startup procedure. Number 1. Make sure that there are no restrictions to the gas flow in the suction and discharge line of the compressor. Open any upstream flow control valves and check that anti-surge control valves are open prior to start the machine. Number 2. Make sure that no liquid has accumulated in the suction and discharge line of the compressor. Number 3. The running in of the main air blower and the catalytic cooler fluffing air compressors can be done via their anti-surge lines. Be sure that the blind and discharge lines of the main air blower is in the closed position and that the control valves in the discharge system of the fluffing air compressor are closed and the controllers in the manual mode to avoid that any air can enter the regenerator. Number 4. The wet gas compressor can also be run in with air. For this purpose, open the mainway covers on the suction vessels and remove gate valves downstream. The anti-surge valves with these opening to the atmosphere, the compressor can be started. Number 5. During the running in of the compressor, monitor all important information like oil, pressure, temperature, bearing temperature, etc. Okay, service and calibrate instrument. Normally, instrument lead lines will be tested hydrostatically up to the block valves when the balance of the unit is tested. Hydrostatic test pressure will not be made on instrument which normally handle gas and no pressure measuring element should be subjected to test the pressure. Okay. Never pull a vacuum on a pressure instrument or gauge unless it is specifically designed for it. Okay. All instrument air piping should be tested at 7 bar or 100 psig with a compressed air. Soap should be used on all joints to check for leakage. Care should be taken to ensure that this high air pressures is not put on any instrument or control valves or diaphragm. Likewise, when the pressure testing the unit must be taken to the fuel gas pressure balance valves or blinded off to keep the high pressure of the diaphragm. Before starting up, all instruments should be serviced and calibrated. This includes carefully measuring all office plates or boards with a macrometers. So the next topic is dry out applied heater. Okay, dry out applied heaters. Before a heater is put into service for the first time, it will be necessary to slowly expel the excess moisture from the insulating concrete setting by gradually raising its temperature before an appreciable load is put on the heater. To be assured of a long heater life with a minimum maintenance, this work must be done with extreme care. For the initial startup, it is favorable to combine the dry out of the heater lining with the dry out of the reactor regenerator section, which we are going to discuss on later stage. Next is the leak testing. Okay, leak testing. Leak testing is performed atypically with air or nitrogen. It is usually performed on sections of the unit rather than the whole unit at one time. When leak checking, it is important the personnel involved stay organized and document leaks are found. The easiest way to accomplish this is by flagging any leaks noted and have a repair team follow closely behind the leak checkers. Okay, number one, have on hand a large quantity of soap, squirt bottles and a colored tagging tab. Also needed a couple of 5 gallons buckets. Number two, break the unit up to in sections to be tested. In case a leak cannot be fixed with the system under pressure, only that section has to be depressurized. Leak checking on the other areas can continue. Number three, stay organized. Start at one end of the sections and work your way through to the other ends, checking all the flanges, well fitting and instruments, etc. Number four, tag each leak found. Also log the location of the leaks on the list to make it easier for maintenance and next shift to find it. Maintenance crew should work along with the leak checking crew as much as possible. Number fifth, exclude pumps and compressor from the system because the sealing system of these atoms of the equipment have the tendency to keep when not in operation. Okay, use large quantity of the soapy water when tested. Okay, it is preferable to do that leak checking shortly before startup. This minimizes the chance of new leaks developing through additional maintenance. Next, okay, generalize a procedure to be used when leak checking. Number one, isolate the section to be tested from the rest of the unit. Do not add additional branch to do this. Block wells should be sufficient. Number two, slowly pressure the suction to 1.8 bar G with nitrogen or air. Listen or large leaks or open valves walk through the entire section. Okay. Okay. Monitor the pressure for 1 hour with low range pressure gauge. If the pressure loss is less than a 0.07 bar G, continue with the test. If the leak rate is greater than a 0.07 bar, check the block wells and blinds isolating the section from other and start a leak checking. Okay, number four, slowly pressure the suction to be tested to 7 bar G or designed pressure if less. Monitor the pressure for 1 hour. Start systematically leak checking the unit with plenty of soapy water. After all leaks have been made, a repair and the pressure gauge holds with 2% of the test pressure for 1 hour, the test is complete. Number 8. Depressurize the sections rapidly through low point well to maximize the water removal from the unit. Okay, the last, remember, a good tightness test is very important for a safe and smooth startup of the unit. These procedures are only frames and have to be developed in detail on the site. Okay, reactor regenerator dry out or refractory dry out initial startup. To protect refractory material, refractory lining in the regenerator, riser and parts of the reactor must be cooled before it is used. Failure to do this appropriately will result in a premature failure of important protection. The dry-out procedure is time-consuming, but once the refractory has been cured, subsequently startup will use a shorter procedure. Minor repair work will not require a high temperature cure, but sufficient time must be allowed for air drying. In all cases, the refractory manufacturer's guidelines should be adopted or consulted. The initial startup separates the unit at the reactor's vapor line inlet to the main column. The vapors line is blinded at this point and the vapor line vent opened. Any work remaining on the column's wet gas compressor and gas concentration section can continue while the dry out is in process. Curing the refractory involves three types of water, free absorbed and chemical bonded. The free water must be removed slowly to prevent rapid expansions to steam that could damage the refractory material. The absorbed water is removed and the refractory dries during a long, high temperature steps. All of the refractory must be dried. Be sure that air is directed to every part of the refractory regenerator system. Okay, so the refractory heat soaking at specified temperature and duration. Number one, raise the regenerator and reactor temperature 10 degree C per hour to 120 degree C and hold at 120 degree C for 24 hours. Okay. Raise regenerator and reactor temperature at 20 degree C per hour to 400 degree Celsius and hold at 400 degree C for 12 hours. Number 3. Raise the reactor temperature at 25 degrees C per hour to 510 degrees C, maximum 550 degrees Celsius, and the regenerator temperature at 25 degrees C hour as high as possible and hold this temperature for minimum 12 hours. Do not exceed 650 degrees Celsius on air heater outlet. Okay. Catalyst loading to hoppers. Handling FCC catalyst is a relatively simple job. Zeolite catalyst is a relatively strong material which will function quite well if it is not mistreated seriously. Because of its characteristics of being easily fluidized, it is easily moved to and from the unit using the principles of pneumatic conveyors. Before the catalyst is loaded into the hoppers, all lines and vessels should be inspected. The important points to be checked: number one, all lines and vessels are built according to specification. Number two, pressure taps are unobstructed and the level gauging devices are working. The lines and vessels are free of foreign materials, especially water or oil. The air lines should be checked by blowing all lines until they are clean and dry. The large diameters loading lines can be blown using the hot air from the regenerator during a dry out. Any water in the lines or hoppers will from sticky mud that makes normally handling impossible as wet catalyst is extremely difficult to remove. The catalyst must be loaded on the hoppers by blowing it in from the supply vessels, evacuating hoppers and vacuuming it in, or combination of the two. A vacuum can be pulled on the hoppers by commissioning the ejector. After lining up the valves to appropriate hoppers, open the loading valves first to the hopper top, then at catalyst loading area. As the catalyst arrives on the side, in a big bags, a small cone-shaped open hopper is located in this area. Okay. Storage hoppers would be evacuated and a small amount of carrying air could be supplied at the base of the cone to help move the catalyst. It is very important when the transferring catalyst to storage that the fresh or low metals equilibrium and equilibrium catalysts are loaded into their appropriate hoppers. This is due to the great difference in activity between fresh and the equilibrium catalyst. A pressure increase on the local pressure gauge indicates a plugging of the catalyst or transfer lines, reduce addition of the catalyst into the transfer lines until the pressure has come down. The amount of catalyst in the storage hopper should be made regularly. A chart showing tons of the catalyst as a function of outage will give a quick inventory reference. This can be calculated knowingly that the hopper volume as a function of the height and the catalyst densities of the appropriate 800 kg per meter cube or 50 pounds per foot cubic for fresh catalyst and 880 kg per meter cubic or 55 pounds per foot cubic for the equilibrium catalyst. More exact value of these multipliers can be obtained from the catalyst data sheets or calculated after knowing weight of other catalyst has been loaded into the appropriate hoppers. Knowing the amount of the catalyst remaining in the hoppers is the only way to control inventory and determine how much catalyst is being used in the unit. Okay, purging and blanketing gas. It must be remembered that oil or flammable gas should never charge into process lines or vessels indiscriminately. The unit must be purged before admitting hydrocarbons. These are many ways to purge the unit, and ambient conditions may dictate the procedure to be followed. Nitrogen or inert gas purging, displacement of air by liquid filling followed by the gas blanketing, or steaming followed by the gas blanketing, etc. For the main column section and gas concentration sections, steam purging followed by the gas fuel blanketing and can be used to free the unit. The reactor is steamed just before starting the unit. So the following are the potential problems or hazard which can occur during steam purging. Number one, collapse due to vacuum of equipment which is not designed for vacuum. This equipment must not be allowed to stand blocked in the steam. Thus, the vessels must be vented during steaming and immediately followed up with the fuel gas purge at the conclusion of the steam out. Number two, flange and gasket leaks, thermal expansion and stress during warm-up of the equipment along with dirty flange faces can cause a small leaks at flange and gasket joints. These must be corrected at this time. Number three, water hammering. Care must be taken to prevent water hammering when steam purging the unit. Severe equipment damage can result from water hammering. Conclusion. Today we have discussed inspection and running in pumps, the break-in compressor, a pre-startup checks and startup procedure, service and calibrate instrument, dry out a fire heater, leak testing, reactor and regenerator dry out, catalyst loading. Next topic will be FCC unit startup procedure and gas concentration section. Okay. These are a few references. Okay. Together, everyone achieve more. Please do not hesitate to send me your feedback and comments t.masood.dr@math.edu. You can also send me text message through my WhatsApp number as I have provided. Thank you very much and stay blessed.